Howdy, I am Tom Christensen of Neurochrome. In this video, I will show you how to build a pair of these Neurochrome LM3886 done right amplifier modules. There are many LM3886 boards on the market today, but most of them, quite frankly, are not that great. The LM3886 is a great chip amp when you take care of it right. And that means you have proper decoupling, you have a couple of compensation components, and also you need a pretty decent circuit board layout. So some of the mistakes I see in a lot of the cheap boards that are available is that A, the decoupling for the LM3886 is either insufficient or flat out not there. The other thing I see is that the components required for good stability are missing. And finally, what also seems to happen is that the power supply is brought in from opposite ends of the board, and that sets the stage for power supply induced distortion. And all of that degrades the performance of the LM3886. And I'm of the firm believer that if you spend your good money buying a kit of any kind, you should at least get the datasheet performance promised by the manufacturer of the chip amp itself. So that's what I deliver here. And if you're curious about how well this amplifier performs, I have a full data sheet on my website on the product page for the LM3886 done right. So this amplifier is available as a stereo kit. That kit comes with all the components that are necessary for populating the board. In addition to the amplifier modules, you will need to provide a chassis, a power supply, connectors and switches, and also you need a little dab of thermal grease to put on the backside of the LM3886. You can find that at computer repair places. It's usually called Arctic Silver, or that's a common brand name anyway, but there are other options as well. The only reason I don't provide that with the kit is that there are some shipping restrictions sometimes, so it makes it a little hard to ship. In the kit, you will find a bag of resistors, a bag of ceramic capacitors, a bag of electrolytic capacitors, and a bag of sort of miscellaneous stuff. You will also find the two circuit boards, of course, and you will find this bag that contains semiconductor devices. And as you can tell, it has this yellow warning label on it telling you that the devices inside are sensitive to static electricity. Now, what does that mean? Well, it means don't shuffle your feet on carpet and then go zap on one of the pins of the ICs, for example. Also, it means keep the parts inside the bag until you're ready to use them, i.e. until you're ready to stuff them into the board. To assemble the kit, you need some basic hand tools. You need a pair of side cutters, you need a pair of needle nose pliers, you need a flat blade screwdriver, and you need basic soldering tools, so a soldering iron and some solder. All right, let's build something here. When I assemble a circuit board, I prefer to work from low to high in terms of component height, and then from least electrostatic sensitive component to the most electrostatic sensitive components. And that means that in this case, the resistors go in first, then the ceramic capacitors, then basically everything else except the semiconductors, they go in last. So let's start with the resistors. When you get the resistors out of the bag, you'll notice that there's no writing on the tape or anything like that. The resistance of the resistors is indicated with the colored bands on the resistors themselves, and that's in accordance with the resistor color code. And I have listed the color combinations on the bill of materials for you. But if your color vision isn't awesome, just measure the resistance with a multimeter. There's no shame in that. For the two or power resistors per each board, there is these guys, and they are marked clearly with 2.2 ohms, so that part is easy. I find it easiest to work by value. So here I have all the 24 kilo ohm resistors laid out, and I will just populate them one by one, and then I'll move on to the next value. To get the resistors into the board, I find it's best to use pliers to bend the pins. I have seen examples where people just shove them in and tug on the pins or whatever, and that gets kind of messy and ugly. It's much easier to just use a pair of pliers to bend the pins. So let me show you how. I start by placing the resistor over the resistor footprint so that it's centered on the footprint. I then grab the lead right at the inside edge of the mounting hole. I then bend the resistor lead, then shove the resistor back into the board. I'll get in there. There we go. and then grab the resistor lead again at the inside edge of the mounting hole right there, and then bend the pin. That's really all there is to it. Then you just shove the resistor into the board. I like to keep them oriented so that the colored bands are oriented in the same direction, i.e. so that you can read from left to right or from up to down on the circuit board. But you just stuff the component in the board like that, and then bend the pins 45 degrees or so, just so it doesn't fall out. And now I'm ready to solder. This anti-static mat is a bit sensitive to heat. So what I do is I have this circuit board, an old circuit board that I have kicking around. I use that as an underlayment like that, so that way when I heat up the resistors, they don't just melt themselves into the anti-static mat. So now I'm ready to solder. And grab some solder here. And let's do that. Like that. Ta-da! Now all I have to do is to cut off the ends here. Like that. You want to cut the pin just above the solder joint. So basically you'll end up leaving maybe 1 millimeter of the pin sticking through the board. And now I'll just solder the rest of the resistors. I'm not going to force you to watch that. And also, by not including that in the video, it means that I can get my fume extractor going here. The solder flux fumes that come off the solder when you heat it up are not exactly healthy to breathe, so I recommend setting up a fan to blowing them away from you, or get a fume extractor like this one that has a charcoal filter in it. Also, if you find that you're sort of having to fight with the spool of solder and it just kind of gets in the way all the time, what you can do is to unspool a length of solder like that, and then just twirl it up on your fingers like that. And now you have a handy package that fits neatly in between your thumb and index finger, and you can solder like that. That just makes it a lot easier. I now have all the 1/4 watt resistors populated on the boards. And as you can see, I've left the power resistors out for now, and that's because they need to sit a little bit proud of the board, and that means that they get a little bit tall, and it's easier to get the ceramic capacitors in before you put the power resistors in. So let's move on to the ceramic capacitors. And that's what you see here. So most of them are thankfully on tape, so they are kept together by value. The loose ones are all 220 picofarad. The capacitors are marked with a 3-digit code on one side and then some alphanumeric code on the other side. So they are actually fairly easy to tell apart. And for example, 220 picofarad will say 221. So that's 22 and 10, or 220 picofarad. I know this one happens to be C5, so I stick that into the footprint for C5, hold it with one finger on one side like that, and then bend the pins about 45 degrees. And that's just so the capacitor doesn't fall out when I solder. Like that. So this is what the board looks like once you have the 1/4 watt resistors and the ceramic caps populated. Next up are these power resistors. And they need to be mounted a little bit proud off the board, so there needs to be a little bit of space between the board and the resistor itself. And the easiest way I find to accomplish this is to, one, get the resistors off the tape here. So let's do that. And then, just as before, I hold the resistor over the footprint where it needs to go, and then I grab, in this case, I grab the resistor lead such that the outside of the pliers line up with the inside of the mounting hole, and then I just bend the lead over, and then do the same on the other side. It's easier if you feed the resistor into the board, double check that you got the positioning correct here, and then bend. And now this should just drop straight into the footprint. And it does. So it just needs to be a little bit, like maybe 2-3 millimeters off the board, just so the resistor can dissipate a little bit of heat if it needs to, and then bend the leads 45 degrees. So now if you put the board upside down, then the resistor will automatically drop down a bit, so you get that little bit of space between the board and the resistor itself. And now all I have to do is solder. So to prevent the resistor from being pushed up once I put the board down, I just put it on the pliers like that. You can usually find a way to balance it like so, and now I solder. Ta-da! With the power resistors mounted, it's now time for a little inductor here, L1, and a pair of Zener diodes. And that's what we see here. Note how the Zener diode has this black band here. That needs to align with the line on the footprint marked right here. So the Zener diodes should go on like that. And just as before with the resistors, I cut the Zener diode off the tape. And then I hold it over the footprint such that it is aligned properly. Maybe it's easier if I rotate the board a bit. Rotate the diode. So I have the black band lined up with the marker on the board here. And then I grab the lead so that the outside of the pliers are lined up with the inside of the mounting hole. And then I just bend the lead over 90 degrees. Stab it back into the footprint. Grab the other lead and align the pliers so the outside of the pliers are aligned with the inside of the mounting hole, and bend over and stuff the diode into the footprint like so, and just bend the leads over 45 degrees or so, and now I'm ready to solder. And just repeat for the other 3 Zener diodes and do the same for the inductors. Next up are the electrolytic capacitors. They are polarized, so you need to pay attention to that. And you can see here the marking on the side of these capacitors, there's a minus sign here. And that means that's the cathode, or the minus end of the capacitor is connected to this pin here. That needs to go into this hole here, so the minus side of the capacitor is marked in white on the capacitor footprint. You'll also find a very tiny plus mark on the plus or anode end of the capacitor. The Nichicon Muse capacitors, these green ones right here, they are special in that they are not polarized. They go into C4, which does not have any polarity marking. Just as before with all the other components, all you really have to do is to make sure that minus is lined up with the minus marking, the white on the board, and you stick the capacitor in, and then bend the leads about 45 degrees. The idea is that the capacitor should be snug against the board, and it doesn't fall out when you rotate the board over to solder. These guys here, the leads come out a little bit narrower than the pin spacing of the capacitor itself, so they will sit a little bit proud of the board, and that's fine. We're almost there. All that's left now is these connectors and some inductors and some mounting hardware, and of course the star of the show, the LM3886. So there is one thing with these connectors when you try to solder them. Of course, if you stab them into the board, turn the board upside down, then the connector falls out, and that's pretty annoying. So one trick that I have for dealing with this is to put the connector in and then allow the solder to drape a little bit over the workbench like that. Then with one or more fingers, I can hold the connector like that and solder one pin. Like that. And now the connector doesn't fall out anymore. So now all I have to do is to do the same for the other connectors and finish off the rest of the pins. And then I'm ready for the inductors and finally the mounting hardware and the LM3886. So here's the almost completed board. The mounting hardware, these brackets here, they are intended to hold the board up against the heatsink. That leaves the front end a little bit as a cantilever. So there are 2 mounting holes here that you can use with standoffs to connect the front of the board to the bottom of the chassis. The mounting hardware, the angle brackets here can be mounted on the top of the board like I've shown here, or on the bottom of the board like this. Just use whatever works best for you in your application. Now it's time for the LM3886. I recommend that you mount the circuit board to your heatsink first before you solder in your LM3886, because it needs to be aligned with the holes in the heatsink and the mounting holes for the mounting brackets. And that's easier to do if you have everything ready. If you don't, like I do here, you just need to be careful to make sure that the backside of the LM3886 is perpendicular to the circuit board. And that can be done by placing the board against a flat surface like that using the mounting brackets, aligning the LM3886 bit carefully here, and then solder one pin on the back side. Then once you have that one pin soldered, you can manipulate the chip a little bit, make sure it's perpendicular to the board, and orient it correctly, and then solder the rest of the pins. Once you have the LM3886 soldered into the board, it's nearly impossible to remove. At least not without damaging the board. It can be done, especially if you have a desoldering tool, but it's a bit tricky, so get it right the first time. And there you have it, 2 completed amplifier modules. Now all that's left to do is to clean the flux off the board and then test the amplifier modules before you put them into service. To test the amplifier module, I highly recommend that you use a laboratory power supply or some sort of power supply with a current limiter. If you don't have one of those and you have no intentions of getting one just for this one project, that's fine. Just make sure that you test your amplifier sort of in stages. So first, power up the power supply. Make sure that you have somewhere between plus minus 10 and plus minus 40 volts on the output of that power supply. Then turn off the power and wait for the power supply to discharge. Then connect the amplifier module. For normal operation of the amplifier, you really need to fit the amplifier with a heatsink, such as this one. This is probably good enough for a stereo amplifier. I don't actually know what the thermal resistance of this is, but I would guess it's around maybe 1 watt per degree, something like that. And that's okay for a stereo amp intended for music reproduction. For sine wave reproduction, you need a beefier heatsink than this. This measures about 20 centimeters on the width and 8 centimeters on the height, and it's about 3.5 centimeters thick with a nice 10 millimeter thick base. So it's a pretty good chunk of aluminum here. And for testing purposes, you can get away without the heatsink though. And that works as long as you don't connect a load to the output of the amplifier. So what I recommend that you do for the first test of the amplifier module is to just power it up, preferably with a current limited power supply, and verify the DC output of the amplifier. And let's do that. I'll just power on my power supply here, and it provides plus minus 25 volts at a current limit of 0.5 amp. And right now the amplifier draws about 50 milliamps. And yeah, the chip just does get a little lukewarm, maybe 40-ish degrees C according to my highly calibrated fingertips here. So now I have the input to the amplifier shorted with a shorting plug. You could get the same result just by connecting input to ground with a piece of wire, but I have these shorting plugs for this reason. And then let's measure the DC output at the output of the amplifier. So I stab my probes in, and the meter reads 0 volts DC. And that's because I have it on the just DC voltage range. If you measure with a cheap meter, that's about what you would get. A slightly fancier meter like this one will have a millivolt setting that we can use. And it still says 0 millivolts, and that's actually kind of impressive. I expect the DC offset of these amplifiers to be below plus minus 2 millivolts for a typical build, and worst case below plus minus 10 millivolts. So this one is even better. I'm actually a little curious what the actual DC offset is, so I'll just hook this up to my 6.5 digit benchtop meter, and let's measure the DC offset now. And it looks to measure about 40 or so microvolts. That's actually pretty impressive. That's pretty neat. That's one of the lowest DC offsets I've seen on an LM3886 in quite a while, so that's cool. Next up, I prefer to measure the gain of the amplifier. It's pretty easy to do actually, and you can do that without any special test equipment. I have a separate video on that that shows you how to do that with either a media player or even a smartphone, along with your digital multimeter. I'll use a signal generator just because I have it. It's a lot easier, and let's just do that. Let's measure the input and output voltage of this amplifier module. I have the signal generator configured for 100 millivolts RMS at 400 hertz that comes in on this coax cable. So I should be able to measure that on the input of the amplifier. And that comes in at 0.1 volt or 100 millivolts. Perfect. Then let's measure the output voltage. And it is 2.005 volts. 2.005 divided by 0.1, that's 20, so the amplifier has a gain of 20 volts per volt, which is the same as 26 dB, and that's exactly as specified. So that's perfect. This amplifier module is now ready to put into service, so get it in a chassis mounted to a heatsink, hook it up to a speaker, and enjoy the music. Don't forget the thermal paste on the backside of the LM3886, something like Arctic Silver works. I use Wakefield 120, Wakefield 126 works as well, and you can find those at Mouse or DigiKey, or just swing by your local computer hardware place and get some Arctic Silver. I hope you have enjoyed watching this video. I hope you found it informative. If you did, or if you didn't, if you have suggestions for improvements, drop them in the comments below. Don't forget to hit the like and subscribe and all that good stuff. And thanks again for watching, and have a good day.